Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Are you looking online institution that can teach you and make you to enjoy and apply the beauty of higher engineering scientific mathematics? If that is your questions, then I would like just to invite you, and I would like to tell you that online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM is the right answer for that question. How are you, everybody who is watching this program? My name is Olenjolai, Marco TAYAI Losingo. Simply just call me Olenjolai. I thank God by His own grace. He has called me to be His anointed engineer and a teacher who is teaching different modules or courses in engineering subjects. So it's only by God's grace that has been upon me, and He has built in me teaching. Teaching is me and I am teaching. Engineering is me and I am engineer. So engineering is me and I am engineering. So I would like to take this opportunity to welcome all the national and international undergraduate students who are watching this program. Whether you're students or you're a parent, you're a guardian, you're warmly welcome. Whether you're Tanzanians or you are Kenyans or you're a student from any African countries or from any Europe country or American countries or from any of Asian country or Asian country, I would like to welcome you to enjoy the beauty of higher engineering scientific mathematics. So I believe that you are ready, and I would like to take you into the interesting point of this little introduction. So I would like to take this opportunity to welcome our online viewer, whether old or new viewer, onto our online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Simultaneously, I would like to welcome you into our official YouTube channel that's called Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAIM. So, what vision do we have in OPITO? OPITO is abbreviations of Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. So this is the vision. We have an assignment from God to teach, train, and incubate some undergraduate students who will be ready to extract knowledge, understanding, and wisdom from the classroom instructions in different courses or modules that we call them fundamental courses and even core courses, and combine it with knowledge, understanding, and wisdom that we are going to teach our online undergraduate students to extract knowledge, understanding, and wisdom, to extract it from the word of God written in the Holy Bible in order to solve real life problems. So our vision has four main parts. The first part will be teaching you how you can extract knowledge, understanding, and wisdom. Remember, education is not knowledge. Education has to be converted into knowledge, understanding, and wisdom so it can have meaningful and applications in your daily life. The second part will be teaching you how you can extract knowledge, understanding, and wisdom from the Word of God. The Word of God is full with knowledge, understanding, and wisdom, but also there are some techniques and some tricks that the Holy Spirit will teach you on how you can extract them. And the third part of our vision, to combine the knowledge, combine the two understanding, combining the two wisdom. And then the fourth part, solving real life problems at the very interesting point. I know you're asking yourself, or possible that after you heard our vision, then you say that this is impossible vision. How can you mix it, the science or mathematics, knowledge, understanding, and wisdom with the knowledge, understanding, and wisdom from the Word of God? I know that. Even myself, when I heard for the first time more than 5 years ago, I thought it is impossible. But right now, I would like to tell you that it's possible, and myself, I'm a good example or a prototype of what I'm telling you. In my own life, I used to apply the classroom wisdom, understanding, and knowledge, and by combining it with knowledge, understanding, and wisdom from the Word of God. That is what I use to apply in order to solve real life problems. So what the main objective of OPITO? So the main objective of OPITO is actually that to train, the main objective of OPITO is to train our students to think differently and think outside of the classroom instructions to solve real life problems. So right now, I would like to ask you to watch our previous video that called Lecture 5. It has been titled Duplication Formula of Gamma Function. In order to know the few steps that you have to follow in order for yourself to register into OPITO or into Online Undergraduate Polytechnic Institute of Tanzania through our official YouTube channel that named as Online Undergraduate Institute of Tanzania in square bracket OLENJOLAIM. But I can just mention the steps quickly because the space today is occupied with the table, with gamma tables, or yes, with gamma table. So the first step, if you have an email, then remember your password and OTP and username. And then the second, in case that you don't have, we ask you to create or open a new email online. The second step, we ask you to sign in YouTube by using your email. So by using your username and the password. And then the third step, we ask you now to search our official YouTube channel for online for undergraduate or bachelor students that titled as Online Undergraduate Poly Institute of Tanzania in square bracket OLENJOLAIM. Once you search it, you will see a round button, right? A round button with Tanzania national flag. And then beside it, on the right hand side, you'll see that Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAIM. You'll see the number of video that right now we thank God by His own grace we've uploaded or published more than 70 videos, but we have a vision of publishing more than 600 videos. So we are still on the journey. So this is continuously processed or continuously programmed that can take even years in order to make sure that we deliver what we have learned in the classrooms, formally and informally, to present and future generation. So then you see the number of subscribers, and then from there, I mean that we ask you to click the round buttons that you are seeing right now. Follow these steps, just step to step, and then you'll be registering yourself into the OPITO as the permanent and active students who will be taking advantage of our content that we are publishing every day in order to change the world. So that you are in the third step. So after you click, you see the trailer video, and then you see the top horizontal bar that returns home, videos, playlisting, channel, community, about. And then below it, you'll see uploads. You'll see also created the playlisting, and you'll see also some related channels at our other 5 official YouTube channels. So from there, we ask you that that will be the first step. The fifth step, we ask you that look the buttons which is written subscribe. It has a background of red and white text. Click it. Once you click it, the text of subscribe will change into subscribed. At the past, it means that we call it a past. We call it just infinitive kinds of the verb. So subscribe. Once you finish that, the icon of the bell will appear on the right hand side beside the word subscribed. So click that icon of the bell. Once you click, you see 3 options. The first option, choose the first options, which is written all. From there, you have already registered yourself into the permanent students of Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. So whenever we publish any video, then you'll be given notifications as long as you'll be online. So whenever you be online at any time and anywhere, you can access our content right now and receive the information. Again, another thing that we like to reduce your hassling on searching consecutive or systematic lectures of the particular topic and particular module or course. We organize our teaching or our training in form of the departments, course, and topic. So we create a particular playlist to present a department, to present a module or course and to present also a topic. So right now, just to go on the top horizontal toolbar and then search the word that has been written playlist, click there and then find a playlist which has been written gamma and beta function. There you'll find the collections of all lectures in systematic way from the first lecture to the last lecture of gamma and beta function. So even if that will be going into the second topic of the modules or course called advanced calculus that called the Fourier integrals and the Fourier transform, then we create its playlist and we find the collections of video, so that the technique and that the capability of YouTube and actual that it's an advantage that you can take. So you find the organized lecture. For instance, this is lecture 6. So you can access lecture 0 to lecture 5 of the previous sessions that we have already published worldwide. So another thing again, you can share these contents to the other undergraduate students worldwide. Remember that higher engineering and scientific mathematics, it's a cross-cutting module or cross-cutting course. It's usually to be provided in most of the institutions or colleges or universities by the departments that called departments of mathematics for the non-majors. In some of the institutions, colleges or universities, they call it departments of general study. So you're warmly welcome right now. Ladies and gentlemen, you're warmly welcome into the departments of higher engineering and scientific mathematics. The modules or the course that we have today is called the advanced calculus, and this is covered in the first year of Bachelor in Engineering and or Bachelor in Science, NTA Level 7 of NACTE. NACTE is abbreviations of National Council for Technical Education in Tanzania. Wonderful. So we'll be focusing on competence based. So we are in chapter 1 that called gamma and beta function, and then this is still the first subtopic of gamma function, and we are in lecture 6 that titled as gamma tables. Okay, gamma tables or gamma table, that's fine because we have different tables. So ladies and gentlemen, in previous, let me just do the quick review. Let me start with quick review. So let us go into the business. Quick review of what? Quick review of lecture. So quick review of lecture what? So quick review of lecture 5. So in lecture 5, simply we taught you about the concept that we call duplication formula. If you missed it, you can take advantage because you can access lecture 5, which is called duplication formula of gamma function in our online or in our official YouTube channel that called the Online Undergrad POLYINSTIT of Tanzania Square Bracket OLENJOLAIM. So what is this duplication formula? I told you how you can derive duplication formula. It's gamma of n plus a half, and this is equal to what? So this is equal to, we say under root of pi, then times what? Times gamma of what? Of 2n, then divided by what? By 2 power 2n minus 1, then gamma of n. So this is what we taught you for the duplication formula, and we say that it is used in the duplication formula. It is used to find. So it is used to find what? It's used to find the gamma function. The gamma function of what? Of higher fraction, of higher positive. You have to limit positive fractions. So for example, if you're looking, for example, gamma of 103 over 2, simply if we break this one, this is gamma of 101 plus what? Plus a half. So what 103 plus a half. So you find from this formula n is equal to 103. So you substitute your right hand side and then you evaluate gamma of 103 rather than using the previous technique that we taught you in lecture 4 that was splitting this one of using recurrence formula, that we say this is 100 over 2 times 99 over 2 times 97 over 2 times 95 over 2 times 93 over 2. So continuously. So that's what we've been teaching. And then we left the homework for you that if you do remember that just to find the gamma or the value of whatever weight, gamma of just the positive fractions over another positive fraction. We solved it and we solved these 3 questions relating to normality or multiplication formula. So today, let us continue with gamma table. Say gamma table. So we say that we have a brief instruction for you, but we say that in some cases, we say that the recurrence, in some cases whereby the recurrence, some cases where the recurrence, formula fail. So in some cases where the recurrence formula fail, recurrence formula and the other properties, not only recurrence formula and other properties fail to evaluate, fail to give or to give the computational results of gamma function, So you say that then gamma tables may be used. So in case whereby the recurrence formula and other properties fail, to give the computational results of gamma function, then gamma tables may be used. Artifact. So it means that, remember, this is a Tanzania's and this is our national flag. So we can use recurrence formula and other properties. How many properties of gamma I've told you? 3. Gamma of n plus 1 is equal to n factorial. Gamma of n plus 1 is equal to n gamma of n. And then gamma of n times gamma of 1 minus n is equal to pi over 2 over sine of n pi. So I told you 3 properties. So in case those 3 properties fail to give us computational results, then the gamma tables may be used. Okay, maybe used it to compute the gamma function. Maybe used it to compute gamma function, Okay, so what is gamma tables? The next question, because you see in the first phrase I have shown you the importance or applications of what? Of gamma tables. Applications of gamma tables. Applications of gamma tables. So, ladies and gentlemen of undergraduate, say that gamma. So, what is gamma table? Okay, what is gamma table? So, what is gamma table? So, ladies and gentlemen, the answer for this question is a gamma table is a table of that represents what? That represents numbers and they are corresponding, teaching in different style. They are corresponding what? Gamma function. They are corresponding gamma function of a specific interval that used to computed gamma function with aid of other properties, of what? Of gamma function. It seems like it's a long definition of gamma table, but it's not wrong. Simply keywords. So gamma table represents what? Numbers, and they are corresponding what? Gamma function of a specific interval. And what the use of these gamma tables, we use them to compute gamma function with aid of 40 of other properties of 40 of gamma. With aid of properties, not other. With aid of properties of 40 of gamma. So gamma tables, simply it's defined in a specific interval. So on the blackboard, we have example of gamma table. We said a gamma table represents numbers. So these are the numbers, which we call them X, or it has been called X in this table. And corresponding gamma function. So these are the corresponding gamma function of these numbers on the left-hand side. And then of a specific interval. So this is not gamma table for every number, but it's a gamma table within this interval in two decimal places from 1 to 1.99. So from 1 to 1.99. So we have millions of numbers within this specific interval. And then used to compute gamma function with aid of 40 of properties of gamma function. So this table, we are going to use this table to compute gamma functions of different numbers, but sometimes we may also combine gamma table, the power of gamma table, and properties of 40 of gamma function on computing the gamma functions of other numbers outside of the given interval. And I will give you. And I want to tell you that, my dear student, when I was doing my undergraduate studies at the Dar es Salaam Institute of Technology some years ago, right? I was in the second year of Bachelor in Electronics and Telecommunication Engineering. Then I learned different concepts of gamma function, beta function, Fourier integrals, and Fourier transform. Then I attempted the test one. So when I went to answer the some 4 questions of the test one that was testing my understanding about gamma function, one of the questions was the questions of using gamma tables to evaluate gamma function. Unfortunately, myself, during my preparations, I have never learned this concept. So I failed at all. How can I use gamma tables to answer the first question in test 1 of my exams of advanced calculus? So what I'm teaching you, actually, it's an outcome, or it's a mistake that I did myself, that I went in test 1 without knowledge of what of gamma tables. So I used to learn from mistakes, and I used to teach other students not to commit the same mistake that I committed myself. So I like to insist you, my dear students, to be careful and to take these contents seriously. I know that most teachers, they need to skip this part, but these are the 3 questions. They use actual to ask you, and they use actual to test you, because your teacher might give you 25% and you have to look for 75%. And you know where are you going to get the 75%? In OPITO, in Online Undergraduate Polytechnic Institute of Tanzania, square bracket, Olenjolai. So take this advantage, my dear student. What I'm teaching you, it's a mistake that I did it during my studies, right? So I don't want you to do the same mistake because I love you so much. Do you understand what am I teaching you? So keep enjoying the beauty of gamma tables. So these are the definitions of gamma tables. But ladies and gentlemen, before we use this gamma table, I would like to teach you a very important concept that we call overview. So because we have a limited space of writing, in case you find that I'm writing quickly rather than my speed, you can pause the video and copy the notes and then you continue. That's the trick. Overview of what is of gamma tables. So let me teach you about overview. Let me teach you overview of gamma tables. Overview of gamma table. Overview of gamma tables. So first of all, so this is the thing that you note. So say that the gamma table are given in a specific are given in a specific interval. A specific interval. So this is table. Let's say this is table 1. Okay. So example. In table 1. Okay. The interval is what? 1 less than or equal to x less than or equal to 1.99. That's the first concept. When you go to the second fact, most of the gamma tables used to have 11 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And rows, it may be 10 or it may be more than 10. So it means that table, let us learn gamma table from table 1. Table 1 has what? Has 11 columns. Ladies and gentlemen, the first column of any gamma table is first column. The first column represents what? The numbers in one decimal place. So the first column represents numbers in decimal place. So this is 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. Right? So represent the numbers in what? In one decimal place. That is the steady point that I have to make. The first point about gamma table. Say the first row represents the second decimal place. Second decimal place of a number. And this number is labeled as x. The first row, when you say first row, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the second decimal place. So for example, if you want to find the gamma of, for example, that this is gamma function of 1, for example, this is gamma function of 1.00. This is gamma function of 1.01. This is gamma function of 1.02. This is gamma function of 1.03. This is gamma function of 1.04. For example, if you go to the 10th column, this is gamma function. This is gamma function of 1.90. This is gamma function of 1.91. This is gamma function of 1.92. This is gamma function of 1.93. This is gamma function of 1.94. This is gamma function of 1.97. This is gamma function of 1.99. So that is the meaning of the first column and second row. So for example, we say that gamma of what? Of 1.22. This is equal to 1.2. So 2, it's what? 0.9131. Then gamma of what? 1.97. Gamma of 1.9. Then I got the second decimal place is what? 7 is what? 0.9977, etc. Happens. The 50 point, because I want you to understand gamma table. Tell your neighbor, do you want to understand gamma table? Then if you have any question, please interact with me in the comment section. So the 50 point is the remaining column and rows. So remaining columns, the remaining 10 columns, first column, second column, third column, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th column. So it means that we represent the gamma function of the corresponding number. So we take that the second from the second column to the 11th column represents gamma function of different numbers in 4 decimal place, in 4 decimal places, in 4 decimal places. So you say that the second column to the 11th column represents the gamma function of different numbers in 4 decimal places. So this is the only one. So this is 1.0. So so gamma of 1.00 is only equal to 1.000. All the remaining gamma function are in 0 point something in decimal places. So it means that this one is 0.9943. So only this one is 1.0. So don't claim like in this case that because here it is 1.0, so it is 1.95. No. These are 0.0. So here we have 0.914, 0.9182, 0.8975, 0.8873, 0.91086, 0.918. For example, this one is 0.88859, 0.9584. So this is what 0.8856. This is 0.8872, 0.8870, 0.939399. Okay? So this is what 0.9476. This is 0.8857. This is 0.9238. So excepting gamma of 1.00, which is 1.000, all the remaining gamma function start with 0 point in 4 decimal places. That's the overview that you have to understand. Okay? So as I gave you an example that gamma of 1.22, it's 0.9131. Gamma of 1.97 is 0.997. 0.997. Wonderful. So if that's the case, I believe that you have understood about gamma tables, and right now you are saying Olenjolai, take us into problem solving. So that's the point that where we are heading to. In case you have any question, don't hesitate to ask in the comment section. This is the national program. I'm teaching all the institutions, colleges, and universities unenacted, which are focused on the competence-based, for example, the Excellent Institute of Technology, and hence, for example, Arusha Technical College, and also, for example, Beng University of Science and Technology, Karume Institute of Science and Technology. I'm teaching them about the beauty of advanced mathematics. Okay, so if that's the case, we say that, ladies and gentlemen, let me take you into problem solving. And I would like to start with what? I would like to start with the problem I faced myself in test 1 of my exam. So example, so this is example 14. And then I ask you to refer DIT test 1 of academic year 2015 to 2016. Okay, and this was question 1. This was question 1. The first question in a test 1. So the question states that that table, gamma table, is given. So use table 1 to evaluate the following. To 3 decimal places. To 3 decimal places. To 3 decimal places. Roman 1 gamma of 0.37 and Roman 2 to evaluate gamma of negative 1.3. If you do that, you will be rewarded 5 marks. Again, have to note, remember that I told you, in some cases, so to find gamma function of numbers outside of the given specific interval, then we have to combine gamma table and the recurrence formula. We have to combine gamma table and what? And recurrence formula. Okay, recurrence formula. Because the recurrence formula can convert the number outside of this range into the number within that given range, and then so use the gamma table to evaluate. So, solution. Remember, this question was a very difficult question in my test 1. So I ask you, please concentrate. Solution. So you say that use table 1 to evaluate the following 2, 3 decimal places, right? Okay. So the first step, we say that check if the given number is within what? Is within the specific interval, within the given specific interval of a number in table 1. Okay, table 1. So we say that the given interval in table 1 is 1 less than or equal to x less than or equal to 1.99. So, from Roman 1, we say that we are looking gamma of what? Of 0.37. Then we say 0.37 is outside the given range. It's outside the given what? Outside the given range. Or the given range from 1 to 1.99. So it's less than. So it's outside the given range such that 0.37 is less than the smallest what? The smallest interval is less than 1. So if that's the case, we go for the second state. In the second state, we say that use recurrence formula to express 0.37 within 1 less than or equal to x less than or equal to 1.99. Okay, so if that's the case, you say that recall gamma of n plus 1 is equal to n gamma of n. Okay, so that's the fact. So you say that divided by n. So you say that gamma of n is equal to what? Gamma of n plus 1 over n. So now to convert gamma of 0.37, this is equal to what? Gamma, our n is 0.37 plus 1. Divided by what? N, the value of n is 0.37. So this will make gamma of what? Of 1.37 of what? 0.37. So the next thing, then we find that 1.37 is within the given range. So is within 1 less than or equal to x less than or 1.99. So if that's the case now, we say that we go for the third step. So third step, we say that now use table 1 to evaluate what? Because you cannot use recurrence property gamma of 1.37. So suppose that this is equation 1. So you say that from table 1 above, say that the gamma of 1.37, this is equal to what? So gamma of 1.37, we start with 1 decimal places, gamma of 1.3, this is 1.0, 1.1, 1.2, 1.3, this is our destination. The second decimal place is 40, is 7. So 7. So 7 we just come into there, we have to move down up to first row. So this is the response. So gamma of 1.37 is 0.8893. So it is 0.8893. Right. So if that's the case, now we say that, suppose that this is equation 2. So we go for the first step. The first step, we say that substituted. Remember that one of the teaching aid that God has given me to teach you high engineering scientific mathematics is by using steps, and we are writing what we are doing in order to simplify your revision process or your revision journey. So substitute equation 2 in equation 1. So substitute equation 2 in equation 1. Okay, so equation 1, it's gamma of 3.7, gamma of what? Of 0.37, which is equal to gamma of 1.37 over 0.37. So this one is 0.88, what? 0.8893 over 0.37. Okay, so now use your scientific calculator, and here we have also very important information that we do have also online undergraduate library where you can access some other useful materials for your learning process of higher engineering scientific mathematics. So in your library, we have original scientific calculator. For example, this is Casio function 991 MS, it's original. So you have number 1 and number 2. So it means you have original and nearby original scientific calculator. So this one, you can order it with a price, the very minimum price of 55,000 compared to the price in the local shops. And for the number, this is number 1. So for number 2, you have to order it with the price of only 35,000 Tanzania shillings. And how are you going to order? So you have to send an SMS of your order. So the telephone number 0759745331, and then we'll call you back in order to accomplish this business. And we can send it to you in any of 31 regions of United Republic of Tanzania. All right. So it's a gamma of 0.37. This is equal to it. So take your scientific calculator. We've used the table 1 to evaluate gamma of 1.37, which is 0.8893 over 0.37. So the response is 2.035. Okay. So are we limited to 3 decimal places? So the response is 2.4035. Okay. So you can add these words if I forgot in example that your answer should be in 3 decimal places. So add this phrase in the question that I gave you. So it's 3 decimal places. So you say that therefore the gamma of 0.37, this is equal to 2.404. At the response 40 for Roman 1. For example 14, Roman 1. Then we have example 14, so we say solution of example 14, Roman 2. We've been asked to evaluate gamma of negative 1.3. In the given table, which is table 1, which is table 1, we have gamma within a specified positive interval of a number x, number called x. But in the question, we have been asked to find gamma of negative, and then we have to use table 1. Table 1 does not have any negative number. It just have positive number in first column with the second decimal place in the first row. So how are we going to navigate? So we have to use, first of all, recurrence formula to simplify or to convert negative 1.3 to be a number within a defined or a given interval of 1 and 1.99. So ladies and gentlemen, so this will be what? So this will be the first step. So you say that check if the given number is within the given interval. So if it's within the given interval, then you have to use the table directly, the given interval. And the given interval is 1 less than or equal to x less than or equal to 1.9. Okay. So we know that negative 1.3 is outside what? The given range. The given range. So because it's outside the given range, so we have to go to the second step. Second step, we say that use recurrence formula to express what? Negative 1.3 within 1 less than x or less than or equal to 1.9. Which recurrence formula do we have to use? Gamma of n is equal to gamma of n plus 1 over n. So gamma of what? Of negative 1.3 is equal to gamma of negative 1.3 plus 1 over negative 1.3. So this will make gamma of what? Negative 1.3 plus 1 is negative 0.3 of what? Over negative 1.3. So this is equation 1. Again, let us ask ourselves this question. So on the right hand side we have gamma of negative 0.3. Is negative 0.3 within the range of 1 less than or equal to x or less than or equal to 1.99? The answer is no. If the answer is no, then we have to keep on simplifying it. Sure? So we go for the third step. Third step, say that express negative 0.3 within 1 less than or equal to x less than or equal to 1.99. Right? How? So we say that gamma of negative 0.3, this is equal to gamma of so this is equal to gamma of n, which is negative 0.3 plus 1 over n, which is negative 0.3. So we say that gamma of negative 0.3, this is equal to gamma of 0.7 over negative 0.3, and this is equation 2. Again, another question that we have to ask ourselves as mathematicians is 0.7 within the range of 1 less than or equal to x less than or equal to 1.99? The answer is no. So we have to keep on expressing 0.7 within the range of 1 less than or equal to x less than or equal to 1.99. That's the first step. The first step, you say that express what? Express 0.7 within what? Within 1 less than or equal to x less than or equal to 1.99. How? So you have to use recurrence form. So gamma of 0.7 n is equal to 0.7 is equal to gamma of 0.7 plus 1 over n, which is 0.7. So gamma of 0.7 is equal to what? Gamma of 1.7 over 0.7. So this will be our third equation. Is equal to gamma of 1.7 over 0.7. This is our third equation. So right now, gamma of 1.7 is within the given what? The given range. Within the given what? The given range. So because it's within the given range, then we got the fifth step. The fifth step, we say that let us substitute equation. This is the teaching aids that God has taught me that I use myself to enjoy the beauty of high engineering and scientific mathematics, and that's what I'm teaching you. So substitute equation 3 into equation 2 first. So the equation 2, we have gamma of 0.7. No. The equation 2 was what? Gamma of negative 0.3, which is equal to what? Is equal to gamma of 0.7 over negative 0.3, and this one gamma of 0.7, so is equal to negative 1 over 0.3 times gamma of 0.7, which is equal to gamma of 1.7 over 0.7. So the new equation for now will be what? Will be negative of gamma of 1.7 divided by 0.3 times 0.7, and this will make a negative gamma of 1.7. So use your scientific calculator to multiply. So I say, in case you lost your scientific calculator, don't panic. Just order it from online undergraduate library. So it is 0.21. So here we have 0.21. So ladies and gentlemen, gamma of negative 0.3 is equal to negative gamma of 1.7 over 0.21, and this will make equation 4. So you have equation 4. We got the sixth step. The sixth step, we say that substitute equation what? 4 into equation 1. So into equation 1, what is equation 1? Equation 1, we are looking gamma of negative 1.3, which is equal to what? So after simplification, we found that here we have a gamma of negative 0.3 over negative 1.3. So simply, this is negative 1 over 1.3 multiplied by gamma of negative 0.3, which is equal to negative gamma of 1.7 divided by 0.21. So negative is positive. So here we have gamma of negative 1.3. So we have what? So in numerator we have gamma of 1.7, which within 1.7 is within the given range, which is 1 less than or equal to x less than or equal to 1.99. And then here we have what? 1.3 times 0.21. So this is equal to what? Gamma of 1.7. Then we have what? 0.21 multiplied by what? By 1.3. So it is 0.273. 0.273. So, ladies and gentlemen, we go to the seventh step. Seventh step, you see that now let us use table 1.0, table 1, to evaluate what? To evaluate gamma of what? 1.7. 0, because it should be in two decimal places. Gamma of 1.7, this is 1.7, 0. So the response from table 1 is 0.9086. 0.9086. 0.9086. 0.9086. Okay. So this will make your equation 5. Equation 5, now this will make equation 6. So this is equation 5. So then take equation 6, substitute into equation 5. Take the value on the right hand side, substitute into equation 5. So you say 8 step. So you say that substitute equation 6. So ladies and gentlemen, the 8th step we have to substitute equation 6 into equation 5. Gamma of negative 1.3 is equal to 0.9086 over 0.273. So 0.9086, then over response. The response is 3.328. 3.328. The response is 3.328 in 3 decimal places. That's the solution. So this is what I was supposed to do. So ladies and gentlemen, this is what I was supposed to do in my test 1, and I failed to do it. So for you, I believe that you are going to enjoy it and you are going to do great things. So you have to make sure that you enjoy our content. Okay. So before I end this lecture 60, before I end lecture 6, I would like to leave the homework. And this is example 15. It's homework 6 and its concept. So try to solve these questions yourself and then submit your solution in the comment section. Use table 1, this table 1, to evaluate Roman 1, gamma of 0.68. Roman 2, to evaluate gamma of negative 1.8. Roman 3, to evaluate what gamma of negative 2.3. Roman 4, to evaluate gamma of negative 1.69. Very simple. For my students, in case that you find any challenge, please just go back to the concept that I have taught you and refer example 14. How I solved example 14, because example 14, Roman 1 was dealing with positive number and Roman 2 was dealing with negative numbers. So there's nothing new there. You just have to combine the power of recurrence formula and the gamma table to evaluate this gamma of the given numbers. Ladies and gentlemen, this is the end of lecture 6. I thank God who have created me in his own image and likeness. And I thank God who have given me a gift of teaching. And this is my freewheeling thanksgiving to all the undergraduate students in Tanzania of present and future generation, and even other international undergraduate students worldwide. That's why I'm offering this content free of charge. It's my freewheeling thanksgiving to God who have given me this special anointing of teaching the beauty of higher engineering and scientific mathematics to engineers and scientists. So I would like to invite you in lecture 7 and lecture 8 when I will be teaching you about applications of gamma function. How do we apply the concept, the properties, the gamma function formula, the formula of gamma function, the properties of gamma function, just the concepts of gamma functions of the positive fractions, and the gamma functions of the whole numbers on evaluating or on solving improper integrals. That will be lecture 7 and lecture 8. I'll be solving in lecture 7. I'll be solving 4 problems. I'll be starting from the simplest problems to the intermediate problem. And lecture 8, I will teach you 4 problems, and that will make total 23 problems or questions about gamma function. Join me again in lecture 9 when I'll be teaching about beta function, and lecture 10 I'll teach about problem solving in beta function, and lecture 11, 12, etc. until we cover the topic of gamma function. So we still have more than 7 incoming lectures, or more than 7 incoming lectures of gamma and beta function. I thank you very much for joining me, and I thank God who have given you opportunity. Please give us a feedback that you're enjoying these contents from which institution, college, or university in Tanzania or worldwide. Tell us in the comment section. Again, give us the feedback, because we like to have a closed loop system. And this closed loop system, or we call it just because we have open gain and closed gain, right? So it means that we have inverting and non-inverting op-amp. So non-inverting op-amp, we say that the feedback is very important. So we're asking you to give us the feedback whether you understand, because in our physical teaching, we used to ask our students and they have to answer that question. Do you understand us? They have to answer on the piece of paper or in a particular column when they are writing their names and regions where they come from. So tell us in the comment sections whether you have understood, or use the comment sections to establish the group discussions with other students worldwide. But give us feedback about how do we teach you. Do you understand us? And give us also what should we improve, because this is ongoing program. And we still have so many lectures about advanced calculus. Later on, we'll teach about Fourier integrals and the Fourier transform. Later on, we'll teach you about the partial differential equation, Hit equation, wave equations, and Laplace's equations. Later on, we'll teach you about vector calculus. I will be teaching about the gradients, divergence. We'll be teaching about the double integrals, triple integrals. We'll we'll be teaching about Green's theorem, we'll be teaching about how you can find the surface area, and we're dealing with different concepts. So stay tuned and keep enjoying the beauty of higher engineering scientific mathematics. Right now, we'd like to reduce your stress on the classroom instruction. Later on, we'll challenge you how you can take these instructions to solve real-life problems. Until we meet in the next sessions, let us meet in the next lecture 8, lecture 7, when that I will take you from the point where you are to the next point. Remember that Olenjolai sings different, Olenjolai sings different, and Olenjolai act differently, and Olenjolai teach differently, and Olenjolai does not know everything about advanced calculus. I just know a small portion of it, but have a responsibility to teach other students, or to teach other students, or other peers, or other colleagues. So may God bless you and keep you until we meet in the lecture 8, lecture 7 or 40 of advanced calculus in the topic of gamma and beta function. May God bless you and keep you.